When science meets fire, water doesn't burn, it dances. Welcome to the Leidenfrost Effect. When water hits a superheated surface like a frying pan on high heat, it should instantly evaporate, right? But no, it dances. It skates, it spins, it does a little shimmy. It's like the water has a personal relationship with the flames, a fiery tango. But how does water dance with fire? To understand this crazy chemistry, we need to get up close and personal with some serious heat. Our trusty blowtorch is cranked up to 2,000 degrees Fahrenheit, about 1,100 degrees Celsius. That's 7 times hotter than an oven and 3 times hotter than a blowtorch. At this temperature, the air around the flame is superheated. And when water hits that hot air, it turns into steam instantly. Now, you might think that the water would just sit there and steam away. But at these high temperatures, there's another wild effect going on. The water droplet starts to levitate. That's right, it dances on the flames. Here it is in slow motion. You can see the droplet doing this weird wiggle. What's happening here is really wild. The bottom part of the droplet hits the hot plate and turns into vapor almost immediately. This creates a cushion of vapor between the water and the plate. And because there's still liquid water on top, it's like a tiny raft floating on a cloud. This is the Leidenfrost Effect, named after a German physicist, who first described this crazy chemistry in 1758. So how long does this last? The short answer is not long enough to learn the entire periodic table. But if you have excellent hand-eye coordination and a steady flame, you can make this last for a few seconds. It takes practice, patience, and a blowtorch. And it's not just a neat trick. This effect has real-world applications. Scientists are using the Leidenfrost effect to develop new ways to cool computer chips. Computer chips generate a lot of heat, and they need to be cooled down to prevent overheating. Traditional methods of cooling chips involve using liquids or gases, but these can be expensive and inefficient. The Leidenfrost effect offers a new approach by levitating tiny droplets of water on a layer of hot vapor. This could lead to cheaper, more efficient chips that run cooler and faster. It's also helping scientists understand superhydrophobic surfaces. Some materials are naturally water repellent, like the Lotus effect. We're studying how to create new materials with similar properties for applications in medicine, manufacturing, and energy. And it's not just about science. The Leidenfrost effect is also a reminder of the beauty and wonder of the natural world. When you see a water droplet dancing on a flame, it's hard not to be amazed. It's a reminder that even in the most extreme environments, life and science can find a way to thrive. You've seen the science behind the dance. Now it's time to put your knowledge to the test. Can you make the water dance on fire? So, show us your moves. Share your videos and photos with us. Use the hashtag provided. Your experiments could be featured on our social media channels. So grab a blowtorch, some water, and a camera, and let's see what you got. But remember, safety first. Be careful when working with fire and hot surfaces. Always wear appropriate safety gear and work in a well-ventilated area. When pressure makes you rise, sometimes fire makes you float. Share and subscribe if you believe in dancing through the heat. Until next time, stay curious. There's a whole universe out there and it's all dancing on fire.